Good afternoon. So we are going to talk about customizing Zabbix. That part will be mainly done by Nathan. I will talk about a little bit about the company and our use case. So this use case is formed within Alliander. Alliander is a Dutch grid owner. We occupy or put our products in 1/3 of the Netherlands. And what we do is we transport energy, like electricity and gas. And next to that, we have our own telecommunications network on 450 megahertz. I will tell you more about it later. We are working together with open source ICT solutions. And as I said, Nathan will do the rest. My name is Edwin Muller. I'm consultant telecom smart meters. My main focus is smart metering. But I also do the OT operations like lighting and intelligent nets.
All right. My name is Nathan Liefting, Zabbix consultant and trainer at Open Source ICT Solutions. Basically what I do 40 hours a week is Zabbix, so I'm very blessed to actually be able to do that. If you could, thank you. Open source ICT solutions. You might also know me from the Zabbix book. Actually, we just released, when Zabbix 7 was released 3 months ago, the Zabbix 7 book. So you can go check that out if you would like to do that.
Yeah. So I told you about our own 450 megahertz network. So, and Alliander Telecom is a department within Alliander. We are part of the 450 megahertz Connect organization. Alliander owns 25% of that partnership, like with E.ON and the 450 megahertz Alliance. So the specific use is of course monitoring. I heard a lot about fixed networks, glass fibers. That's totally different than mobile communications, and that's why we needed a kind of customization. We also own Trend, and we migrated our glass fiber network. So Trend does glass fiber. We migrated that with our own glass fiber, and now we cover also 1/3, about half of the Netherlands, with our own glass fiber network to monitor substations. But not everything can be glass fiber, of course. That's too expensive. So we do the main parts with glass fiber, and the remaining parts are mobile. For this, at the moment, we are trying to integrate all the grid owners. Like there are 3 main ones, Alliander, Stede, and Nexus, and we are trying to go together. We own our own base stations, so we also do the base stations next to the commercial providers, and then we try to make a really good coverage of all the assets in the Netherlands. So which are these assets? First, on the left side, you can see the smart meters. We have around 3.2 million of these smart meters. And the other 3 devices are routers. What we do with them is distribution automation, around 10,000. Street lighting, around 20,000 routers. They are based in the substations, so we can steer in a small area all the lighting. Power quality, to maintain the quality of the electricity in the net. Alarm indicators when something goes wrong. Gas automation, and so gas is also monitored, and other cases. What I see in the business is that they get more and more devices because everybody wants to know more about the grid, and especially real time. And that's hard to do with mobile networks. So that's why we did some tuning. So why? Health, performance, and availability. So it's not obvious that a network is always available. There will be outages, there's bad coverage. Next to a base station you will have good coverage, but the farther you come away, the harder it is to get your data. We don't only monitor our routers, but also the chain. So there's a readout system, and there's a hardware, and there are APNs, VPNs, the whole chain we want to measure. And of course, with the routers, there can be one router failing, but there can also be many routers failing. And that we also want to see, because then something like a tunnel is down, or a firewall is closed, or so that's why we use Zabbix. We also collect the metrics. One of the metrics is, for example, the firmware. If we do a mass firmware update, yeah, maybe 80% succeeds in one time. But then you want to know which devices are not upgraded. And so we maintain a current overview of all the firmwares. We also want to look at the wireless signal quality and the signal-to-noise ratio, because the mobile network is not constant. And when there's a truck passing by, you can already have a bad mobile signal. Also, we see that weather influences are quite important. For example, when it's warmer, we see that the radio signals, they tend to get more noisy. So, up-to-date wireless network provider information. That's a really new technology. You used to have one SIM card, one provider. And recent innovations, we are working now with the eSIM. eSIM is electronic SIM. It is not a SIM card anymore, but it's soldered on the breadboard. It can have many SIM cards inside, and you can do that with remote SIM provisioning. So we have a system, we can push SIM cards to the smart meters remotely. So we don't have to switch the modem, the SIM card, or the meter anymore. Also, we did this because we don't want to have a lock-in in our system. We want roaming, multi-MC, so multi-providers, and we do that with different technology. And soon we will be able to have multiple profiles and select the best SIM card for each location. It's very location dependent. So we monitor dashboards, or we make dashboards, and we also can say something about the providers, that one provider is good in cities, other providers are good in countryside. But the main focus is cost management, because every byte that you send, so for example, you have 3,000 devices. Mobile is quite expensive. You pay a few cents per SIM card per month. But do that times 3 million, and you can see what the cost of mobile communication is. And that's why we work together with Nathan to optimize really the data traffic.
Thank you. So, now we are presented with a little bit of a problem, because Zabbix has a plethora of features, but one of the things that we were missing in this case were some customizability that we had to do to get around them, actually. For example, when you're using these eSIMs, it is quite useful to know what provider is currently being used by one of these routers. So that's the problem that we were presented. Now we want to filter based on those providers, and we want to make sure that you can actually get that information. So that's why we have the tags. And the tags, well, right now they are quite static. You set something up on a template level maybe, and it is actually inherited on the lower levels. But what if we have this dynamic information like Vodafone, T-Mobile, KPN in the Netherlands? Well, if we want to add that to a tag, we can't do that natively. But we do want to see it, like you can see on the image on the lower end. Yeah. So how do we achieve that? Well, that's where the beauty of Zabbix comes in. We have all of this customizability, and we went the JavaScript route. There's various ways to introduce JavaScript through global or item level scripting, but specifically it will be using the duct tape engine. So we are limited to that, although we do get extensive capabilities, and we were actually able to build this using that and a lot more features. It isn't extendable with libraries, but we do get a whole lot of features that we need. Now, specifically, we want to make sure that this item is going to populate that tag. So we create an alert script, and we make an alert script based on JavaScript. Name the script, and then we pass some parameters, like what host do we want to update the information on, what tag do we want to update, the provider tag in this case, the tag value, the token, the URL. So it's all built into the front end. We don't need to do anything on the CLI here. And what do we do with those parameters? Well, we simply give them to the JavaScript. And the JavaScript, we, for example, say, hey, there's an alert coming in. We know which host that is, so we know the host ID. Tag name provider, we'll update that, and we'll use some variables to catch that information in the script. And then we define an API call to actually talk to the Zabbix API. So like I said, we're staying within the environment here. We're not doing anything on the CLI, but we're using JavaScript in the front end to talk back to the Zabbix API and make changes, making it all built in. The API call will simply get the host name through a host get to make sure that we have that, and then we can start to update the tag. And that's not the only problem we were presented with. I think, actually, this is your slide.
Exactly.
So you can explain a little bit the other problem.
Like I said, the fixed networks, yeah, you can send whatever you like, and the mobile networks cost are key. For example, we check the network with Wireshark, and this is an example of a ping. And ping is 200 bytes, 100 bytes to the router and 100 bytes back, if it is successful. In Zabbix you can do a maximum number of counts and the maximum number of pings, ICMP, but then it always executes those pings. And we don't want that, because that can be, if a network works well, we put 3 pings too many. So we want to reduce the number of pings. Also, we own our own network, and our routers go in dormant mode. So they are not accessible, and they only wake up when somebody tries, when we try to ask something to the device. That takes 3,000, 4,000 milliseconds. But that doesn't always is not always taken into account, and you have to program that really well. And yeah, with SNMP, it's less configurable to do that. Also, in mobile communications, it's useful to wake a router by first sending 1 ping. When it's awake, you do the SNMP reading. And that's what we made also. So, to elaborate even more, to get more data, we want to know how many pings were used to get a successful connection. So, and when we only try 4 times, and when it still doesn't work, we don't even send out a SNMP anymore, and we don't bother a network even more, because we are not the only one using the network, also not the commercial networks, a lot of people on it. And if everybody does this with such many devices, then it will be quite full soon. Then the commercial networks, like LTM, LTE, GPRS, they all have different timings. And so we needed quite some customization to make the optimal settings for every ICMP call.
All right, so like I said, presented with another problem. We want to reduce cost, and we want to reduce the amount of bytes that we are sending over the network. Now, Zabbix usually assumes that we have all of these fiber or, at least copper connections, gigabits of data that we can cross over, but this isn't the case in every single network. So what do we want to do? We want to reduce those pings, and also we only want to execute SNMP if the ping is actually successful. So that's 2 problems there. What will we do? Well, we'll do the ping. We'll make it a little bit more efficient by saying only send the required amount of pings. If you succeed at 1 ping, the rest is probably also fine. Don't worry, stop right there. And then we'll execute SNMP. Once again, we need a little bit of customization because we do not have a max retry option in the fping built in. So we just write a little bit of a bash script, nothing too fancy. It's just very simple script. Run through it, do a loop, and then send that back using Zabbix Sender. The interesting part comes when you actually want to execute the SNMP right after that ping. And that's where we're going into some custom JavaScript again. Basically, what we'll do is whenever a ping is received and it is successful, we use a no data trigger to make sure that if new data has come in the last 30 seconds, so the shortest interval we can do, then will create a new problem. And with that problem, we can start to actually do a whole bunch of stuff because we can use those alert scripts again. We can set up an action. If the event comes in, well, then you execute something. What do you execute? Well, a bit of JavaScript that is going to talk to the API again. No data will also automatically resolve after 30 seconds, so we can have an update interval for the ping of 30 seconds or slower. We add a tag to this event as well, so that we have something that we can actually put the action on. But you do have to keep in mind, this does create a lot of events. We actually already thought of maybe a better solution to do this by using a script item instead. But as it is implemented right now, we are creating a lot of events because there's like 20,000 devices. So let's set up that script. We execute SNMP. Can we execute SNMP through the Zabbix API? Yes, we can. We set up an alert script, parse the parameters again, so we want that host ID, API token, and the URL. And then we communicate internally, localhost to the Zabbix API. And what we'll do is we'll simply create or pass those parameters, add some error logging, of course, to make sure that if something goes wrong, we can easily read it in the Zabbix server logs, and then execute the actual call. Now, the call is quite simple here. We simply get the item data first, so we use the host ID to get the SNMP get item, which is just a bulk item that is executing basically all of the SNMP on this device. Once we know the item ID of this SNMP get item, we can use that data in a second API call, and that second API call is going to use task.create. And task.create with type 6 creates an execute now. So we basically do an execute now through the API for this specific SNMP item once the ping was successful. Of course, to do that, we'll need the action, so we'll create an execute SNMP action, value of tag execute equals SNMP, and then the execution step, the operation, will be run the script, execute SNMP. We'll use the item ID and the host ID to execute the SNMP get bulk request to get that data into Zabbix, only when the ping succeeds. One thing to keep in mind, though, is we still have an update interval on the SNMP get item, so we just use a schedule check to make that as long as possible. We can't disable it altogether, but it will still reduce the data enough so that it is viable for this environment. In Zabbix 7, we can even make this a little bit better. We aren't running 7 yet in this environment, so what can we do? Well, we can set up SNMP get bulk, but there's actually an issue in this specific case with bulk, because bulk actually adds some additional bytes in overhead, and we are very stingy about the bytes. So what do? In Zabbix 7, we can use the SNMP get again in a single item, add all of the OIDs that we need to the get item, and then we can reduce the data even further. So waiting for Zabbix 7 upgrade to get that done as well.
Yeah, what I forgot to mention is that not only there was the walk that generates more data than necessary, but also the individual readouts of SNMP OIDs makes a lot of sessions. In our own network, I told you that the devices go in dormant mode, and it means that every time we get a value by SNMP, the device needs to wake up again, and that is also not good. So one use case is for walk, that's okay, but that generates data. The other use case is sessions, and that generates extra wake up of the hardware. Well, what are the benefits now? We came from 4.4 that had a very basic configuration. We are going now more towards near real time, and we generate much more data about our devices. Now we made some nice dashboards, and we can see where the weak spots are in the network, in the devices, and we can really focus on those things. We have more focus. We are busy with integration of ServiceNow. I heard before with CRM software. Well, we try to do ServiceNow in the future. Network management system, including all peripherals. So we see actually a quite of chain monitoring. We can really see our multiple devices affected in a specific area, in a specific substation. So we have much more detailed data. Historical data for identification of trends. So this means that if there are certain devices always reacting in the same time, we will find it. We also already went back to some manufacturers that some basic things in the firmware were not so good, so we can improve on that. And with this customization of data, it really enables to use minimum data and minimum sessions. So thank you for your attention. And are there any questions?
So we have one more slide.
Oh, we have one more slide? Oh, that's... Oh, I'm
one
sorry.
More. No
that
worries,
was a new
no
one.
worries.
I didn't practice that one.
Yeah, we did add this one later. So yeah, just a little summary here. What we really want to show you here is, of course, how are we using Zabbix, but also you can be quite creative with your Zabbix environment to extend it. You know, Zabbix has provided a lot of additional tools for you in the built-in JavaScript to actually extend it all within Zabbix. We don't need very lengthy Python scripts running on the CLI with cron jobs and everything like that. We really wanted to keep everything self-contained here because it's a very close and secure environment. So customize, but also use the tools in your Zabbix environment internally to do that customization. I'm no JavaScript guy, it's not a lie. Usually I do like Python a little bit better, but this is included, so it does give you that really tailored customization. So use those script items. Also, we put some ZBX Next on the screen here for the ICMP paying max retries and the execution dependencies that we would really like to see to get this, internalized in Zabbix. But we can already do it just by using the customization options. All right, and I think that's it. And now we can go to the questions if there are any. Thank you very much.